Deep in the montane rainforests of Central Africa lives a frog that breaks its own bones on purpose. Not by accident. Not as a symptom of disease. Deliberately. As a weapon. This is Trichobatrachus robustus, the hairy frog. And almost nothing about it follows the rules that govern the rest of its kind. Frogs are ancient creatures. They have been on this planet for over 250 million years, long before the dinosaurs rose and fell, long before mammals inherited the warming world. In that span of geological time, evolution has shaped thousands of species into an extraordinary range of forms: poison dart frogs bright as traffic signals, tree frogs with feet that grip glass, desert frogs that seal themselves in mucus cocoons and sleep through years of drought. The frog body plan has proven astonishingly adaptable. But the hairy frog arrived at solutions no other amphibian ever found. It lives in the humid highlands of Cameroon, the Democratic Republic of Congo, Nigeria, and Equatorial Guinea, clinging to existence in fast-moving streams flanked by dense forest. The water runs cold and clear over volcanic rock. The canopy above filters the equatorial light into something green and diffuse. This is a landscape of perpetual moisture, where the boundary between land and water is less a border than a suggestion. The hairy frog is not small. Males reach up to 13 centimeters in length, large by frog standards, with a powerful, muscular build that hints at the unusual life they lead. They are predominantly brown and olive, patterned to disappear against wet stone and leaf litter, which is precisely what they need to do. The forest has no shortage of predators. Snakes, birds, small mammals, all of them would happily swallow a frog whole. What makes a male hairy frog immediately recognizable during breeding season is the extraordinary texture along its flanks and thighs. Thin, finger-like strands emerge from the skin, not fur, not feathers, nothing quite like anything seen elsewhere in the animal kingdom. These are dermal papillae, elongated projections of skin, each threaded with a network of tiny blood vessels called arterioles. They are, functionally, external gills for an adult animal. Here is the problem the hairy frog has solved. During breeding season, a male guards a clutch of eggs attached to submerged rocks in fast-moving water. He stays. He does not leave. The eggs require continuous attendance, other creatures would consume them without hesitation. So the male plants himself in the current and holds his position, sometimes for days, consuming almost no oxygen through his lungs because surfacing would mean abandoning his post. The hairs are his solution. By dramatically increasing the surface area of his skin in contact with the oxygenated water rushing around him, he supplements his breathing through cutaneous respiration, absorbing dissolved oxygen directly through the skin. The more surface area, the more oxygen. The hairs are not decoration. They are infrastructure. No other frog has evolved this particular answer to this particular problem. It is a reminder that evolution does not consult a manual. It does not move toward predetermined elegance. It finds what works, regardless of how strange it appears. But the hairs are not what earned this animal its other common names. Locals in Cameroon call it the horror frog. Scientists, in an uncharacteristic moment of enthusiasm, have called it the Wolverine frog. The reason lies in what happens when a hairy frog is threatened, what it does in the fraction of a second between danger and death. The toe bones of most frogs are connected to surrounding tissue in the ordinary way. Bone anchors to ligament, ligament to muscle, the architecture of movement functioning as it has throughout the vertebrate lineage. But in the hairy frog, there is a modification at the tip of each toe. The final bone segment is sharp, pointed, and it is connected to a small, specialized patch of muscle. When the frog is seized or threatened, it contracts that muscle. The bone snaps forward, piercing through its own skin, emerging as a sharp claw from the tip of the toe. Not a claw grown over time like a cat's, not keratin-shaped across weeks of cellular activity. A bone. Breaking through living flesh. In real time. The process is, by the standards of vertebrate biology, almost incomprehensible. Animals go to extraordinary lengths to protect their bones. They evolve calcium-dense tissue, redundant structural elements, behaviors designed to avoid fracture. Bone damage is costly, slow to heal, potentially fatal. And yet here is a frog that has evolved to break its own skeleton as a first resort. The mechanism appears to involve no passive fracture. The bone tip does not simply crack under pressure. Current research suggests the frog actively drives the process, using muscular contraction to force the sharpened bone through the tissue. The skin seals around the penetration point when the claw retracts, evidence that the body has adapted to manage this damage repeatedly, across a lifetime of confrontations. It works. A hairy frog seized by a human hand will rake those claws across skin hard enough to draw blood. Imagine encountering this in the dark undergrowth. Imagine expecting a passive, soft-bodied amphibian and finding instead something that fights back with its own skeleton. The hairy frog feeds on insects, small millipedes, worms, and, given its size, occasionally small vertebrates. It is an ambush predator in the most fundamental sense, sitting motionless until prey wanders within range, then striking with the sudden explosive power that frog legs were designed to deliver. In the ecosystem of the rainforest floor, it occupies a middle tier, large enough to pursue meaningful prey, small enough to require constant vigilance against the things that pursue it. Its populations, like those of so many species tied to specific forest habitats in Central Africa, face ongoing pressure. Deforestation fragments the highland forest. Streams degrade when their surrounding vegetation disappears. The hairy frog is also hunted and eaten by local communities. It is large enough to be worth catching, and it does not flee efficiently on land. Its extraordinary defenses did not evolve for that kind of threat. Science is still learning the full extent of what this animal can do. The claw mechanism was only formally described and documented in detail in 2008, when researchers used X-ray imaging to capture what was actually happening inside the toe. Before that, the claws had been observed, noted, and largely not believed. Naturalists had reported them for over a century, and the reports had been treated with skepticism. The truth, when finally confirmed, was stranger than the skeptics had imagined. This is what makes the hairy frog remarkable not merely as an animal but as an idea. It exists at the edge of what vertebrate biology was thought capable of producing. There are perhaps 65,000 known species of vertebrate animals on Earth. Of all of them, every fish, every reptile, every bird, every mammal, every amphibian, only one is known to weaponize its own bones by breaking them deliberately. It is a frog. 13 centimeters long. Living in a stream in Cameroon. And it has been doing this, unobserved and unrecorded by science. Thanks for watching. If you enjoyed this, hit like and subscribe for more incredible facts.